Alright, this tutorial is for solving problems involving tension. And in this example, we're going to do one where we have a rope connected to some object with a mass 1, which is connected to a second object with a second rope, and the mass of the second object is given as m2. And in this problem, if we are told that the acceleration of this whole system is moving upwards with some acceleration given by a. So this is a problem involving forces acting entirely along the y direction. So we're not going to consider anything like acting along the x direction. And we're going to start off by defining our positive y to be up and our negative y to be down. All right. So to solve problems like this, we have to consider the forces acting on each of these objects separately. And so we'll start off by looking at the forces acting on object 1 and then also look at the forces acting on object 2. And before we draw free body diagrams, we can make sketches here to tell us where all the forces are acting on, what the forces are acting on each of these objects. Alright, so whenever you have, for object 1, it's connected to this rope with some tension, and the tension is going to be pulling this object up. So the tension here, the rope is going to pull this object up here with some tension, which we call T1 or TA. And at the bottom, the tension here is going to be acting on pulling the box down. And so this is rope B, so we'll call this tension here TB. And for this mass 1, it's also going to experience the acceleration, its weight, the force due to acceleration, the force due to gravity acting downwards. So it's also going to experience another force acting down. So I'm just going to draw it on the side here, and we'll call that M1 times G. Yeah. So when you have a rope and the rope is pulled out, it means that the forces acting on both ends of the rope have to be the same. So if we have a tension TB acting on this side of the rope, then the rope will exert that same force TB on the other object. So we're now going to consider the forces acting on box B. So at the top here is going to experience a force TB acting upwards, which is a tension in rope B. And then it's also going to experience its acceleration due to gravity acting downwards, which will be M2 times G. All right. So since this whole system is accelerating upwards, the net force acting on this object, on this M2, will be up. So the net force is going to be M2 times A. And this object here is also going to be accelerating up with that same acceleration A. So the net force, so we call this F2 net, is also going to be acting upwards. F1 net is equal to M1 times A. Alright, so in solving these problems, we can break them up into the different objects. So we're going to start off with object 1. So for mass 1, let's draw a free body diagram. So we have the object, which we're going to represent as a point, and we have the TA acting upwards, and we have TB acting downwards, and also MG acting downwards. So I'll just draw it on the side again. And we show that the net force acting on this object is up, so F net, which is the mass 1 times its acceleration along the y-axis. So for mass 1, we can apply Newton's second law, which says that the sum of the forces acting in the y direction have to be equal to the mass times the acceleration. in this case the acceleration along the y. And so since we're talking about object 1, I'm just going to put 1 here to represent the first object. Alright, so for object 1, we have the TA acting up. We have mg acting downwards, so we'll put a negative sign there for m1g. And we also have TB, the tension B acting downwards, so we also have to put a negative sign for TB. And that is going to be equal to the mass 1 times the acceleration 1 in the y direction. So if we are given the acceleration and the mass, the only unknowns in this equation are going to be TA and TB. Alright, so to find TA and TB, since TB is also connected with the second mass, we can solve the same Newton's law for the second object. So for mass 2, we'll start off by representing mass 2 as a point object. And so for mass 2, we have the weight acting downwards. So we have m2g. We have TB acting upwards. And you notice that I do not include TA for mass 2, and that's because this second rope here is not directly connected with this mass 2. So the only tension is going to feel experienced is the tension due to rope B. Alright, so the only two forces acting are TB and m2g in this case, and the net force is going to be up, so F net 2 is going to be equal to F2 m2 times the acceleration, which is the same for all the objects. So again, applying Newton's second law, the sum of the forces on 2, so F2y, have to be equal to the mass 2 times this acceleration in the y direction. And from our free body diagram, which we always have to draw for these problems, we have TB, which is positive, and m2g, which is negative, so we just put a negative sign there, is equal to m2 times a2y. And in this case, a2y is the same as a1y, which is the same as a. So we're just going to rewrite, take out the subscript here to make the problem look better. Alright, so if we're given the acceleration, we're given the mass, we know the acceleration due to gravity, then we know that the tension in B is simply equal to m2a plus m2g. And so to find TA, assuming we know everything else, now that we know what TB is, we can substitute TB in this equation here to solve for TA. So here TA is equal to, so I'm going to bring this here over the equal to sign. So we have m1a plus m1g plus TB. So if we put this expression for TB in this equation here, we see that TA is equal to m1a plus m1g plus TB, which is m2a plus m2g. Right. So this is a case where the whole system is accelerating up. If the whole system was accelerating down, this A will be negative. And if the whole system was moving with the same velocity, this A will be 0. And if the system was just standing still and not moving at all, the acceleration will still be 0. And so putting 0 for A, these terms will cancel out, and the tension will be equal to the weight of the object 1 plus the weight of the object 2.